and you will also surprised. Chalo. So you will also surprise that this potential has also bound state, and but we have only one bound state. In general, we have seen that particle in a box, how many bound state is there? Infinite number of bond state for infinite box. For a particle in finite box, how many number of bond state? Finite number of bond state, depends on the strength of potential. In a harmonic oscillator, how many number of bond state? Infinite number of bond state. Okay, all infinite discreteness level is there. Let's try to go for a Dirac delta potential. Okay, so the Dirac delta potential is basically Vx is equal to minus lambda delta x. So at x is equal to 0, we have basically Dirac delta potential, and the strength of potential can be defined by lambda. So you can have something like this. So this is my potential, this is my Vx, and we have to solve for the bound state. So obviously E is less than 0. You can just understand the system something like this. You can assume that a well which is very deep in nature, but that have very less space, or in fact you have 0 space, because you have negative infinite potential at x is equal to 0. So you can assume something like this. In a practical sense, you can assume something like this, that you have this sort of well, something like this, and this is something between minus epsilon to plus epsilon, and where epsilon tends to 0, isn't it? अगर epsilon tends to 0 होगा तो ये मिल जाएगा ना? Yes या no?
Yes, sir.
Yes. So why we can assume for the particle will be bounded for negative value of energy. You can assume that particle is going to bounded for negative value of energy. So we have actually reason 1 and reason 2, and reason 3 is not a reason, that is just a one type of one point, that is x is equal to 0. This is your reason 3. But how we will solve this particular thing, that is mind-blowing idea, and here this picture will come into your mind, and then we can solve it. Okay, so let's try to solve the Schrodinger wave equation into reason 1 and reason 2, and then we will apply some basic property of Dirac delta at the reason 3, and this reason 3 is between minus epsilon to plus epsilon, where epsilon tends to 0. So look at this arrangement of mathematics. Without using mathematics, without efficiency in mathematics, quantum mechanics is, you cannot explain quantum mechanics phenomena. Okay, so let's try to go for this. So obviously we have to solve Schrodinger wave equation into this region. So what is this one? So minus h cut square upon 2m d square psi upon dx square. What will potential here? 0 is equal to E psi, and this can be written as d square psi plus dx square plus 2m E upon h cut square psi must be equal to 0. And please mind it, this E is itself negative. So we have to make this thing positive. What I have to do? And I am solving it for the reason 1. Okay, for reason 1. Same equation will also for reason 2, but solution will be different. Now बताओ क्या करेंगे? If this is your negative, when you are solving differential equation, this must be positive. So what you will do?
So minus लगाना पड़ेगा.
Minus लगा देंगे. Very good. So what we will do? We will use the minus sign. So when we are using this minus sign, then we have d square psi 1 upon dx square minus 2m e upon h cut square psi 1 must be equal to 0. Now this term is positive or negative?
Positive.
Positive. Very good. So I can put some gamma square because here is minus sign. So I always use gamma for the minus sign when this minus sign is there, and k when you have plus sign is there. Okay. So this gamma square is nothing but minus 2m e upon h cut square. So we have this differential equation, and this differential equation is minus gamma square psi 1 is equal to 0. So what should be solution of psi 1? Psi 1 into this region. What is solution of psi 1? क्या होगा? इसके दो solution हो सकते हैं. A e to the power minus gamma x, and second solution is what?
A e to the power gamma x.
A e to the power gamma x. So which one is accepted solution for region 1?
A e to
This
the
or
power
this?
gamma x. A e to the power
Obviously,
gamma x.
this is your
Yes.
accepted solution. This is your,
So you have not pinned it up.
sorry?
तो पिन नहीं किया था.
यार मैंने तो कुछ नहीं, मुझे कुछ करना नहीं होता है, पिन उधर से करता है. सो पिन तो किया हुआ है.
Okay, sir.
सो कुछ प्रॉब्लम हो रही है क्या?
सर जैसे कोई और बोल रहा है तो उसका पूरा वॉल पे आ जा रहा है.
अभी शायद किया है कुछ. चलो सो रहा है कुछ. अभी ठीक है?
ये सर अभी सही है.
अभी सही है. सो रहा है कोई उधर से, जो मैंने इधर देख रहा है इसको. चलो एनीवे, सो दिस इज योर e to the power minus gamma x. Okay, now so this is my psi 1. So I can write psi 1 a e to the power minus gamma x. Now what will be your psi 2? The same solution will be there, same differential equation will be there, but what will be your solution?
So psi 1 में minus नहीं आएगा.
Sorry, psi 1 में minus नहीं रहेगा, that will be plus. Okay.
Yes. Sir.
What will be for psi 2? बताओ. You have again same differential equation ना? Psi 2 के लिए भी तो same differential equation होगा,
E raised to
because
minus
potential is 0.
exactly.
So what will be
Minus
solution?
आ जाए.
Obviously, so I can write b e to the power minus gamma x. This is for x is less than 0, and this is for x is greater than 0. Okay. And now my wave function must be continuous, है ना? At x is equal to 0. So you have x psi 1 0 is equal to psi 2 0. So from here we have a is equal to b. So this is all about our wave function at a must be equal to b. And now we can have this particular wave function into these two regions. And now we can also normalize it. हम लोग इसे क्या कर सकते हैं? Normalize भी कर सकते हैं. Okay. So your psi is equal to a e to the power gamma x, x is less than 0, is equal to a e to the power minus gamma x, x is greater than 0. Some places this can be also written as a e to the power minus gamma mod x, for x is between minus infinity to plus infinity. इसे ऐसा लिख सकते हैं या नहीं? Just check it. ये TFR के एग्जाम में क्वेश्चन था, लिख सकते हैं या नहीं?
Yes, sir.
लिख सकते हैं. What is mod x? Mod x is equal to x for x is greater than 0, and mod x is equal to minus x if x is less than 0. So this can be written something like this. Anyway, so now let's try to go for normalization of this particular thing. So we can go from minus infinity to 0, mod a square e to the power 2 gamma x dx plus 0 to infinity mod a square e to the power minus 2 gamma x dx is equal to 1. Can I say that this integration and this integration is same? प्रूफ कर सकते हो कि दोनों इंटीग्रेशन सेम है?
Yes, sir. First integration में limit.
Very good. First, you can put x is equal to minus y.
Yes,
ना?
sir.
And then you can prove that this integration and this integration will same. और वैसे भी अगर आप इसे प्लॉट करोगे, when you are going to plot this function, then this function is something like this, isn't it? This function is symmetric function. So if it is symmetric function, then obviously you can use 2 times. So I can directly go for 2 times 0 to infinity mod a square e to the power minus 2 gamma x dx must be equal to 1, and we can get a is equal to, so this is 2 mod a square into 1 upon 2 gamma is equal to 1. So 2 and 2 is cancelled. So a must be equal to root gamma. Everyone is comfortable? So what is my wave function now? I can use this particular, and now we have write this as a normalized wave function. So when we are using for the normalized wave function, then we have psi x is equal to root gamma e to the power plus gamma x, x is less than 0, is equal to root gamma e to the power minus gamma x, x is greater than 0. This is interesting. Now there is a one problem into this wave function. What is that problem?
Sir, differentiability को ये.
Very good, very good. This wave function is not differentiable at x is equal to 0. You cannot do anything. So this wave function is not differentiable, but we will use this particular thing, this particular information to find the energy eigenvalue. Now let's try to go at x is equal to 0. So we cannot write differential equation at x is equal to 0. So what we are going to do, we are just assuming this type of scenario when my x is between minus epsilon to plus epsilon, where epsilon tends to 0, we can write a differential equation, or we can write a Schrodinger wave equation, and that Schrodinger wave equation is minus h cut square upon 2m d square psi upon dx square minus lambda delta x psi x is equal to e psi x. लिख सकते हैं ना?
Yes, sir.
Yes. Now we have to solve this differential equation. How you will solve it? So here we have one information that this wave function is not differentiable. So if this wave function is not differentiable, that means there is discontinuity in the first order of differentiation, isn't it? There is discontinuity in the first order of differentiation. So we will use this particular information to get the energy eigenvalue. And one more thing is that whenever you have Dirac delta function in a differential equation, it is much better that you have to integrate in on both sides. So such that you can remove this particular Dirac delta function. Obviously, so what we will do, we will just go for minus h cut square upon 2m d square psi upon dx square dx. We are going to integrate from minus epsilon to plus epsilon minus lambda delta x psi x we are going to integrate from minus epsilon to plus epsilon dx is equal to E psi x dx minus epsilon to plus epsilon, and we have to always take care the fact that this epsilon turns to 0. So means if either you are moving from left side or you are moving from right side, you are reaching the point at x is equal to 0. So what will be this integration? ये इंटीग्रेशन क्या होगा बताओ? Mathematics. What will be this integration?
d psi by dx.
Very good. d psi by dx. और यहां क्या लिखना होगा? माइनस एप्सिलॉन टू प्लस एप्सिलॉन. वेरी गुड. लैम्डा, ये इंटीग्रेशन क्या होगा? What will happen to this integration? अरे ये क्या कर रहे हो? If you have a to b or something, alpha 1 to alpha 2 delta x minus a fx dx, if a is between alpha 1 and alpha 2, what will be this integration?
1.
Hey, f a. F of a. So Dirac delta function will just act as a projection. You project your function at some particular point where Dirac delta is there. That will fa, isn't it? You are just getting this particular fact, है ना? fx की value x is equal to a पर क्या होगी? Then you can do this integration, you will find fa. So in some sense, you are just projecting fx at the point A. You have to use the Dirac delta function. This is wonderful. So now, anyway, so just use this fact. After using this fact, what will be this value?
Psi 0.
Psi 0. Very good. Good. Now, use your mathematical acumen to find what will be this particular value. ये क्या होगा?
सर 0 होगा शायद, इसमें psi
Zero
प्रेजेंट ही नहीं है.
Very good. This value is 0 because epsilon tends to 0. So if
Yes,
epsilon tends to 0, this area is near about 0. So any function, area under the any function at the point is more or less 0. So we can use this fact is 0. Now, after then we are going to solve this particular equation. यहाँ तक clear है? Yes या no?
yes sir.
Yes, okay. थोड़ा प्रैक्टिस कीजिए, है ना? आप लोग प्रैक्टिस कम करते हो. This is not good. चलो. So let's try to go for this equation. यहाँ क्या हो जाएगा? So we have minus h cut square upon 2m. इसे क्या लिख सकते हैं? d psi 1. Sorry, first वाला तो d psi 2 upon dx minus d psi 1 upon dx at x is equal to 0 at x is equal to 0. ऐसा लिख सकते क्या? बताइए.
yes sir, लिख सकते हैं.
बिकॉज इस रीजन में आपका फंक्शन क्या है? e टू द पावर गामा एक्स. इस रीजन में आपका फंक्शन क्या है? सॉरी, माइनस गामा एक्स. इस रीजन में क्या है? e टू द पावर गामा एक्स. सो अगर आप इस तरफ से देखते हो, जीरो के प्लस साइड में देख रहे हो, देन योर फंक्शन इज दिस वन. सो व्हाई वी आर यूजिंग डी साई 2 अपॉन dx एट x इज इक्वल टू 0. अगर आप लेफ्ट साइड देख रहे हो फंक्शन को, देन यू हैव दिस वन. ओके, माइनस lambda psi 0 must be equal to 0. आपके एग्जाम में ये क्वेश्चन आया था, व्हाट विल बी change in first order differentiation. And what will be discontinuity into the first order differentiation? तो यहां से क्या करेंगे, इसकी वैल्यू निकालनी है. We will get it there and we can find the value, है ना? Anyway, तो उसे करने से पहले हम लोग यहां देखते हैं. So we will just differentiate. किस फंक्शन को यहां डिफरेंशिएट करोगे? This one? तो क्या मिलेगा आपको? psi 2 रूट
Minus
गामा
gamma.
माइनस गामा, है ना? And
Yes, sir.
x is equal to 0, that function is 1. Minus psi 1 क्या मिलेगा? रूट गामा गामा minus lambda psi is equal to 0. Either you will move from 0, from positive or negative, you will get the same function because it is continuous. So this value is 0. So you can take root gamma common. So you have 2 gamma h cat square upon 2m is equal to lambda. And from here, we can get gamma is equal to m lambda upon h cat square. And what is gamma? This gamma is minus 2me upon h cat square is equal to m lambda upon h cat square. So what you will get? What is value of E? We will get minus, है ना, m lambda upon 2 h cat square. So this is your energy eigenvalue.
Lambda
ठीक है?
square.
By lambda square. Okay, thank you.
Super.
Into lambda square. Yes. So this is your energy eigenvalue. And this energy eigenvalue is negative. And there is single energy eigenvalue. Only one state is there. Yes or no? Only one
Yes, sir.
state is there. Only one energy eigenvalue is possible. And what you will get? You will get actually. Now we can analyze the thing. यहाँ तक clear है ना? Everything is okay? इसको हटा देते हैं, यही कर लेते हैं. So you can just analyze this particular thing. What you will get? You will get, this is your Dirac delta, attractive Dirac delta, because it is negative. So your function, wave function is something like this. Similarly, your probability density is something like this. And you have this as your energy eigenvalue. And this value is m lambda square upon 2h cat square. Okay. So you can see what you have done. You have put the particle inside the well and you compress it. Particle will go outside the well. There is all particle will be into the classical forbidden region. There is everywhere. Look at this, is going to exponentially down. So classically, you put the particle in a well and you compress the well. Compress the well. What will happen to the electron? It will just go like this, quantum mechanically. Once you put the particle, you compress your well. At some point, you will find the particle will be just into the classical forbidden region, but energy eigenvalue is something like minus m lambda square upon 2 h cat square. That is single state system. Single state system is particle that is in attractive Dirac delta potential. Okay, so this is very important. आपके एग्जाम में जो प्रॉब्लम आया था, they have just asked what will be delta d psi upon dx. क्या हो जाएगा? Delta means change, है ना? What will be this? Lambda psi naught, है ना? यही होगा ना? You will take it here. Lambda psi naught
Into
into
2m
2m upon
h cat square.
h cat square with the negative sign. यही तो होगा?
Yes, sir.
Yes. And what is your psi naught? root gamma. So you can find this particular value. So delta, that is change in differentiation, d psi upon dx is equal to minus lambda root gamma 2m upon h cut square. So this was 1 year problem. Okay. So आप
Sir.
इस तरह से देख सकते हैं. हाँ बताइए.
सर मेरा थोड़ा नेटवर्क चला गया था तो सर कैन यू जस्ट रिपीट लास्ट सेंटेंस वो कंप्रेशन वाला व्हाट यू आर सेइंग.
कंप्रेशन का कह रहा हूँ कि सपोज आपने पार्टिकल को रख दिया, ठीक है,
यस
एक
सर.
वेल के अंदर, है ना,
यस सर.
और वेल को, और वो नेगेटिव वेल है ना, अट्रैक्टिव वेल है, ठीक है, और आप वेल को आप कंप्रेस कर रहे हो, कंप्रेस कर रहे हो, कंप्रेस कर रहे हो, क्या हो रहा है?
पार्टिकल मतलब कम करेगा.
तो उस वेल के अंदर पार्टिकल के होने की प्रोबेबिलिटी क्या हो गई? 0 हो गई. एंड आउटसाइड दिस वेल देयर इज ऑल प्रोबेबिलिटी विल बी आउटसाइड दिस वेल. नहीं,
यस सर.
समथिंग लाइक दिस, है ना, वही तो है.
यस सर.
ओके
ओके सर.
okay, so this is your attractive Dirac delta potential. So we have finished basically one-dimensional system, and in fact we have also finished the two-dimensional, three-dimensional in Cartesian coordinate system. So before going to next level, it is very important that you have to give the test up to this, है ना? So I think 1 or 2 tests will be there. So let me check. So आप पहले उस टेस्ट को दीजिए और प्रिपेयर कीजिए, and then we will go for next level, that is we will solve quantum mechanics in a spherical polar coordinate system where angular momentum and all this thing will come. So but before that you have regularly 2 or 3 tests. आप पहले उसे दोगे and then we will go for next level. ठीक है?
सर रिपल्स, ये हम अट्रैक्टिव रिपल्सिव पोटेंशियल ऐसा कुछ नहीं होता है ना? मतलब
बिल्कुल होता है, क्यों नहीं होता है? रिपल्सिव पोटेंशियल भी करेंगे. ये रिपल्सिव पोटेंशियल हो गया. ठीक है.
दिस पार्टिकल विल बी रिपेल्ड फ्रॉम.
देन यू हैव स्कैटरिंग. तो यहां से आप ट्रांसमिशन कोफिशिएंट एंड रिफ्लेक्शन कोफिशिएंट निकालोगे. ठीक है.
ओके.
सो यू कैन जस्ट ट्राई दिस पर्टिकुलर थिंग. ठीक है. एनीवे, सो जस्ट रिवाइज ईच एंड एवरीथिंग. रिवाइज योर बुकलेट. ओके. रिवाइज एटलीस्ट प्रीवियस ईयर एंड ट्राई टू गिव, आई थिंक 3 टेस्ट विल बी देयर. 3 टेस्ट होगा, उसे आपको करना होगा, है ना. सो लेट मी चेक, और मैं आपको शेड्यूल दे दूंगा. जस्ट ट्राई टू डू ऑल दिस टेस्ट. ठीक है.
ओके सर.
ओके, चलो, थैंक यू.
थैंक यू सर. गुड नाइट सर.
गुड नाइट.
थैंक यू सर. गुड नाइट.
गुड नाइट. गुड नाइट.